Hello, welcome to week two. Um, we are dealing with decimals this week, and in the book it starts on page 40, it goes through page 52. Um, and before we start, I wanted to emphasize last week, I think I forgot to mention in there, is kind of like why we chose the material, or I chose the material to use. Um, I teach this class also on campus, and I gave them an inventory test because I kind of had no idea what to expect. Like, who knew what, how advanced they were, how, you know. So when it came back, it kind of just gave me an idea that a lot of people needed to be kind of reintroduced and run through the decimals, fractions, things like that, because either it had been a while since they had it, and math's one of those things that if you don't continue to use it, um, you lose it. I mean, it's just basically simple. Um, so if there's anyone that kind of maybe you just came out of another math class, or maybe you think like there could be somebody that's like, hey, this is like kind of easy for me, I apologize, but also know that math's one of those things that it's always good to have a refresher. And so uh, hopefully by what I've seen, I think people are doing okay and they're encouraged. So just bear with me, and we'll go and we'll make this happen. So hopefully everyone has the book. Again, this is kind of awkward to be standing here or sitting here talking to a computer screen. I don't have a board. I don't have people looking at me and nodding and taking notes and doing all this stuff. So I just have to assume that what I said comes in clear. But again, I'll say if you have questions, concerns, something that you don't understand, please go to the discussion board, because odds are more than you have a question. So we can kind of get a good thread going to make sure we all understand it. Plus, people are checking the discussion board constantly, I think, and therefore, if it's sent directly to me and I might not get it for several hours, on the discussion board, there's a good chance someone will see it and respond if you have a question. Um, so again, page 40, and I also was thinking about writing stuff down, but I realized when I do that, it comes up backwards on the screen, so that really kind of hinders what's going on. But anyway, as we know, decimals are a part of something. It's breaking something into a fraction, a portion, a smaller part of. It's an amount less than one. So we're talking about getting exact, detailed measurements, or values, and money, breaking money down. So the first lesson we talk about is the decimal point, and then in decimal place values. And as you can see in the book, it gives you an example with the place values where it's tenths, hundredths, thousandths. Most people are familiar with those, at least the terms. And know that the tenths is the first number right after the decimal. The hundredths is the second place. Thousandths is third. Now they keep going into 10,000ths, 100,000ths, millionths, but really the first three are mainly what you'll deal with and see in the book. So tenths, hundredths, thousandths, be familiar with those. And of course we have them on the plus side as well. On the other side of the decimal, the ones, tens, hundreds, thousands. And we won't really deal with anything on that side except a little bit with the ones, because it'll round decimals to carry over to that side, to the left side of the decimal. Again, it's kind of so tricky sitting here talking and not showing, but I'm going to try my best. The example it gives is 13.042. The 0 would therefore be in the tenths place, the 4 in the hundredths place, the 2 in the thousandths place. And how you would say that word or number is 13 and 42 thousandths. When we're talking about saying anything with the decimal, the word and will always imply where the decimal's at. So when you have a number like that, you have a number on the left side of the decimal, you have the decimal itself, and then you have numbers on the right side of the decimal. So in theory, you can split that into like 3 places, but as we go about doing the assignments, I'll show you how really it turns into like a 4-step problem. But number in the front, 13, just like it looks, nothing special about that. The word and always will indicate where the decimal's at, and then afterwards you have 042, 3 places, therefore it's thousandths, and the number's 42, so 42 thousandths. Why I say it's a 4-step problem when you get into doing these, and they're on the bottom of the page there, is what I tell everyone to do is So like the number 9 in the book is 2, excuse me, 2.04. How I'll tell people to attack those problems is write the word "and" down right away. That way it's out of the way. You know that's kind of where your starting point is, even though it's in the middle. But start with that word in the middle. Okay, you got the word "and" that signifies where the decimal's at. In front of it, you have a 2. So just write TWO in front of it. Therefore, you know you have 2 and. Now, why I say it's 4-step, because your next step should be identify how many place values you have. In this case, you have 2, 0, and a 4. So it's 2 places. Therefore, you know by looking at the chart that's hundredths. So you know it's something hundredths. Hundredths would be your last word. How many hundredths? 0, 4. There it's 4. So write the 4 in, therefore, between the and the hundredths. So you have 2 and 4 hundredths. Kind of like 4-step problem. And again, that will go with numbers where you have numbers on both sides of the decimal. So if you have a whole number, dot, decimal places, you're going to have whatever the number is and whatever the place value is, and then how many that is. So again, number 9, 2 and 4 hundredths. For numbers like number 10, where there's a 0 in front of that, but that 0 doesn't hold any place values. So you wouldn't say 0 and whatever. That 0 is just showing you that there's no whole number value in that problem. It's basically 0.140. Therefore, you wouldn't need an and because there's no whole number. It's not and whatever blah, blah. You just skip the and just go right to the decimal place values. There's 3 of them. So 3, tenths, hundredths, thousands would be thousands. And how many? 140. So it'd be 140 thousandths is all you need to write for that problem. And you'll learn later, though, we can actually knock off that N0 too, but we'll get to that later. I don't want to throw in confusion now. Same thing at the bottom, like 5 through 8, when it tells you how to write the number. What I suggest is locate if there's an and in there, write the decimal first. Then whatever's in front of that and, so in this case it's number 5, it's 6 and, so you have 6 dot. And then identify how many place values you need. In this case it's thousandths. I would start out, even if you're not used to this, writing the actual 3 spaces out. You need 3 spaces because it says it's thousandths. Okay? Write the 3 dashes out. How many thousandths? It's only 3. Well, 3 only takes up one of those places. It always goes to the end. Okay? So, I'm going to try to write this down, even though it's going to be backwards, and I'm going to try to have it make sort of sense, because I think this one's one that I don't know how else. Maybe I can do it backwards on here, and that would help out. Let's see. How does this look? The 6 is backwards, but okay. That's a 6, even though it's kind of backwards to you. But there would be my and. Remember, this is backwards. And you need 3 place values, okay? So the end would be the 3. Okay? These would be filled in with zeros. So it'd be 6 and 003 to represent 3 thousandths. Okay? Wish that 6 would come out just a little bit. That's better. 6 and 3 thousandths. Okay? So if you, whatever the amount is in the decimal place values, it always fills in at the end. So in other words, if this was 13 instead of 3, you'd have a 1 here, and then a 3 here, and you'd still have 1 0 here. If it was 113 thousandths, it'd be 113. You'd have no place to put any zeros. You wouldn't need to add any zeros. It would be 113. So 6 and 113 thousandths. Again, I hope that's making sense. Good news too, I don't know if I even shared this last week, the answers should be in the back of your book. Now obviously I'm not saying just go right back and do the answers, but I mean it's a great tool to have in case you're struggling and thinking, am I doing this right, am I not? Okay? So again, the write the number and write the number in words. Pretty basic. Once you're used to it, you'll fly through things like that. I promise you. Once you're used to it. Jumping over to page 41, comparing decimals. I emphasize this so just crazy in the classes I've had in the past and this one, and yet people still continue, I think, to not do what I tell them because they think it's just easier to do it in their head. When you're comparing decimals, I always tell people they're going to write them in the book horizontally. What I tell people to do is take that then and write them vertically and line the decimal up, one on top of one another. Then you can see, plain as day, which ones are bigger than the other ones. And what you'll always want to do is fill in zeros in any empty places or any things to line them up, because therefore you can see the numbers, and it's so much easier. Let's see if I can do one upside down again. Okay, so there's comes up 1.0, 0.1. 0.1, there it is, left right upside down, and 0.2, 0.283. Is that right? 0.283. Oh, this right upside down thing stinks. But anyway, if you write those on top of one another and fill in zeros after the 1, you have 1,000. The next number down, then you'd have 0.283. That's 283. Without even looking at the decimals, 1,000 and 283, 1,000 is bigger. Therefore, that's the bigger decimal. The simpler way of looking at it is you have a 1 in the tenths place, and the second one you have a 0 in the tenths place. 1 is bigger than 0. You don't have to worry about there being any more numbers in that problem. I don't care if that 0.0283 continues on for 1,000 places. It's never going to get bigger than the 0.1. So 0.1 is bigger than 0.0283. Okay. So basically, what I'm saying is line the decimals up, and then write the numbers out. And if one only has 2 numbers, and the other one has 4, add 2 zeros at the end. That way, everything lines up symmetrically. You have 4 digits, 4 digits, and then just look and say which number is bigger, and you'll get it right every single time. Sometimes people will look at it in their head, and some people can do it. I'm not going to argue that you can't, but I think some people just think, well, it's way too easy. I do it in my head, and then you miss the simple ones. And obviously, if there's whole numbers involved, there's numbers on the left of the decimal, like number 3. That 1 in front of the decimal is bigger than that 0 for the second one in front of the decimal. Therefore, that 1.123 is bigger than 0.059. No brainer right there. If it goes down to the second set where there's 3, just do the exact same thing. Line them up, 1, 2, and 3. Fill in zeros if you need to anywhere, and just look and see which number is biggest, which number is smallest, and they'll be easy to line up from least to greatest. Not a problem at all. That should be it for that page as far as comparing. The book shows a really good example of that as far as lining up. What it doesn't do that I do is tell people is to add the zeros in. And if you see at the example, right kind of in the middle of the page on 41, is they have 0.02 and underneath that 0.008. What I'm telling you to do is after that 2 is put a 0, so there's 3 digits after the decimal on that one, and there's 3 digits after the one on the bottom. So it's 0.020, 0.008. Okay? And then you just got to look and say, well, 20 is bigger than 8. Simple. What they're showing you too is also that there's a 2 in the tenth or hundredths place on the one on the top. There's a 0 in the hundredths place on the bottom. Therefore, the top one's bigger. Okay? So either way is correct. Like I said, adding the 0 I just think makes it look, it's pleasing to the eyes. They have the same amount of numbers. You know, we're used to that. Therefore, it's easy. Hopefully that makes sense. Again, I think a lot of this class is going to be required of you to be able to kind of look through the book and, you know, gain it. What I might try to do next week and maybe is video this maybe after my class at school and see if I can set it up where the board is maybe would be, but I still think it's going to come out backwards on here. I don't know. I'll keep looking. I'll keep trying to dig. The next page is rounding. This is a stickler with some people, I think, where I've seen a lot of times in the past, people just seem to have a I don't know, mental block or something, or they overthink it, I think, as far as making it more hard than what it actually is. Um, Rounding is simply, it's a way to, it's to kind of, without dealing with tons of decimal places, there's sometimes you'll see where decimals, if you don't round off, you could divide forever because it's never going to come out evenly. The only three places you'll see rounded to here are the tenths, hundredths, and thousands. Again, I think once in a while, like I said, you'll round off and actually carry over into the ones place. So be wary of that. But for the most part, we're worried about those decimal place values. The example it gives you is the number 0.0916. So if you don't have the book, it's 0.0916. If you're rounding that to the tenths place, the key thing I say to start with is identify what's in the tenths place. So anytime you'll see a direction round to the nearest tenth, round to the nearest hundredth, identify the number that's currently in that place. So in this case, it's the 0. The 0 is in the tenths place. The key then is look to the next number after that. So the number in the hundredths place in this case is a 9. If it's 5 or bigger, which in this case a 9 it is, that rounds the tenths place up one number. It can never round up more than 1. It only can go up 1. If that number is less than 5, so it's 4, 3, 2, 1, or 0, the tenths place would stay the same. It will never go down 1. So the only two options you have are stay the same or go up 1. Okay? Only two options. No more than two options. Okay? So in this case, it's a 9. It's 5 or greater. Therefore, the tenths, which is now a 0, gets rounded up to 1. And as you can see, therefore, your final answer is 0.1. All the numbers after you round off are discarded. All the decimal places are gone. Okay? So if it tells you to round off to tenths, your answer needs to end in the tenths place. Okay? I see a lot of times that'll happen. It'll say round to the nearest tenth, and someone will have 2 decimal places. Well, that's impossible because that doesn't match up with what the directions say. All right. So the very next line, it says round to the nearest hundredths. Identify what's in the hundredths place. In this case, it's 9. After that 9 is a 1. That's less than 5. Therefore, the 9 stays the same, and you just simply drop the 1 and the 6, and it's 0.09. Okay, so that's to the nearest hundredth. Drop the next line down, it's nearest thousandth. Identify what's in the thousands place. It's the 1, it's the third place after the decimal, 0.0916, 1 in the thousands place. After it is a 6, that's 5 or bigger. Therefore, the 1 in the thousands place jumps up to a 2. Everything in front stays the same, 0.092. The 6 gets dropped, and you've rounded off to the thousands place. The only place where these get, it's not even tricky, but just where there's an extra bit of work involved is if you do have a 9. Let's take, for example, that same number, instead of it being 0.0916, let's change it to 0.9916. So same scenario, except we're changing that first 0 after the decimal to a 9. 0.9916. Well, if I tell you to round that to the tenths place, there's a 9 in the tenths place right now. After it is another 9. Well, that 9 is going to bump the first 9 up to a 10, technically. Well, you can't have a 10 in one place value, so you put the 0 there, carry the 1 over to the next place value, which in this case is on the other side of the decimal to the ones place, so you would be left with 1.0. You have to keep that 0 there in that case because you're rounding off. That 0 is holding the tenths place value. So you would not just put 1, you'd have to have 1.0. That's showing you that that 0 is holding a place because you rounded off. So again, if you have 9s that need rounded up, they become a 0, and then the 1 will carry to the next place to the left. So if you had a 9 in the hundredths place that needed rounded up, that 9 would turn into a 0, and then you'd carry a 1 over into the tens place. Okay. Another example, just to say it out loud, is if you had 0.4972 and you're rounding off to hundredths. In the hundredths in that situation would be a 9. After it is a 7. That 7 would bump that 9 up to a 10, but you'd put the 0 there, carry the 1 over to the 4, make that a 5. So it'd be 0.50 would be your rounded off to the hundredths place for that number. And as you can see at the bottom of that page, you're simply just doing a lot of rounding, tenths, hundredths, thousandths place. And again, just a lot of experience. I would do all that page if I was anybody, because rounding is something you will use throughout the whole section. It's not just something you do here and forget about. You're constantly going to be rounding off in the future with decimals. So it's always something, a tool that you're going to use. Therefore, I would try to make it very, very like second nature, that you don't even have to think about doing it. You just kind of boom, do it. The good news is those are probably the two, or the couple easiest things to do. I don't know if I even said that right. Those are probably the most work I would say to get used to. If I said that wrong, I apologize. Is the kind of explaining the place values, comparing and rounding them off. After this, I think it gets a lot easier. Adding and subtracting decimals is next in 43 and 44. Very, very easy rule of thumb to remember is always line up the decimal if you're adding and subtracting. If you notice in the book, again, they always write the problems horizontally. It's much more to your advantage to write them vertically and line your decimals up. Okay, so anytime adding and subtracting, first rule of thumb. As soon as you see how many problems you have, if you have, or how many numbers in the problem, if you have 2, put 2 decimals down, one on top of another. If you have 3 numbers you're adding, put 3 decimals down on top of each other. Make that the first thing you do, and you should never ever get any of these wrong. The problem I see all the time is people want to just rewrite the problem without even thinking about where the decimals are, just to make the numbers line up. They worry about making the numbers line up, not the decimal. Okay, line the decimal up first. You'll never get these wrong. All right, so you can see the example top of the page. You're adding 3 numbers there. You have 41.3 plus 2 plus 0.093. Okay, you have 3 numbers. Put 3 decimals down. Boom. The first number, and then write them just based off where the decimal's at. So 41.3, write it accordingly. Right off the top decimal, 41.3. The second number is a 2. There's no decimal there. It's a whole number. Okay? Very simply, put it in front of the decimal. Put that 2 in front of the decimal underneath the 1. Okay? There's no decimal after it. Therefore, there's no you're not putting zeros, nothing. Just put that 2 in front of the decimal and be done with it. And then you have 0.093, and as you can see at the example, write it off the decimal just like it looks. So when you first write it down, and it looks kind of weird because you got numbers on the left and you got a bunch of open space, you got numbers on the right and open. So it looks kind of weird, but again, that's fine. It looks weird, but it's still set up properly. Now, when you're adding, you don't need to worry about doing any zeros. You can simply add straight down. If you want to, if it helps you, you could always add zeros to make everything line up perfectly. That's an option, but with adding, you do not have to do that. It shows you that in the example. To the right there, you can write zeros to fill the empty places. It says it just like that. I couldn't say it any better. Therefore, when you add those up, 43.393. Now, this is one of the things I say that's not in the book that I emphasize in my class on campus. Probably get sick of me saying it, but I say it anyway. When it comes to sometimes these adding and subtracting decimals things, I say this term, I say use common sense when you check your answer. Well, a lot of times when you say that, it's almost like you're trying to insult somebody. I don't mean insulting at all. What I'm simply saying is it's a way to just kind of mentally check your answer without doing any math, really, and it always helps at the end of a problem just to kind of keep you from making any simple mistakes. So in this case, think of it in terms of money. You got $41.30. plus $2 plus that last number, you kind of like 9 cents, but it's kind of a weird number. But so just rationally think in your head, I'm taking 41. You don't have to worry about the decimals. I'm adding 2 to that. There's 43. Plus I have a bunch of decimal places. Now look at your answer and see where your decimal's at. 43 point a bunch of decimal places. You should be good. What I see a lot of times, I'll see a problem like this, and I'll see an answer with like 4.3393 or something like that. Now if you look at the problem and say what I say about using common sense, you already are starting with 41 point something and are adding to it. Therefore it's going to get bigger. Your answer has to be bigger than 41. So if you look down at your final answer and just think, wait a minute, I have 4 point something, I only have 4. That should just right away clue you I did something wrong. I either added something wrong, or most likely I have the decimal in the wrong place. I cannot emphasize enough, how many times you can catch yourself from a wrong answer just by simply stepping back at the end and applying common sense. Okay, I've seen it way too many times. When I taught back in the prison, I just would pound that in their brains. Use common sense to check your answer. Don't go back and check it with the math, because that's what got you in trouble in the first place. All right, step away from the decimal thinking and just kind of go, wait a minute, I got $41. I'm adding 2 to it. I need to at least have like 43 something in my answer, and I promise you'll save yourself a bunch of headache down the road. All right. So quick review on that section. It's just simply lining up the decimal. If it's a whole number without a decimal, it's in front of the decimal. Don't forget that. And once you line them up, fill it in just like it looks, and you shouldn't have any problems with that section at all. I think that's probably one of the easier things you'll do. The very next page is subtracting decimals. Very, very little difference. There would be one little thing we'll talk about here at the top, but the main thing to remember, same principle, the decimals need to be lined up. And as you can see, they're written vertically, write them horizontally. Or they're written horizontally, you want to write them vertically. The example up top, 12.7 minus 0.16. Remember also, it's just like old rules of subtraction. The first number always goes on top, second number always on the bottom. Okay? And as you can see there, when you line the decimals up, it's 12.7 subtracting 0.16. There's nothing above that 6. Okay? When you're subtracting, you have to add the 0 up there. You have to subtract the 6 from something. So we're putting a 0 up there, and then you have to borrow down just like you would regular subtraction. Okay? So 12.7, take away the 0.16, 12.54. All right? So the difference between adding, you do not have to add the zeros. You can to make it look good. Subtraction, you do have to have the zeros added. Okay? And again, I emphasize common sense. You go back to the original problem and say, okay, I have $12.70. I'm subtracting just like 16 cents. Therefore, my answer should be still $12 and something. If you get to your answer and you only have 1.254, I only have like $1 something, okay, something's wrong. I lined up the decimal wrong. I did something wrong. Okay, so just kind of, again, at the end, use common sense, step back, look at the problem just as a generic problem. Don't think of it mathematically. And as you can see at the bottom, those are just a bunch of subtraction problems. Make sure 8 through 12, they kind of wrote it into more of a statement than they did just a basic problem. You'll see if you're looking at the book. So make sure it's, how you read that correctly, it's 47 cents subtracted from $1.15. So make sure the $1.15 is on top, the 47 is subtracted from that number. Okay, so just when they turn into a word problem, just make sure you know that when it's subtracted from, then that last number will be the one on top minus the whatever is being subtracted from that number. Jumping over to 48 and 49, we are multiplying decimals. The great news about multiplying decimals is we no longer have to worry about lining them up, so that's kind of out the door. The rule of thumb with multiplying is set it up just like you would a regular multiplication problem. If I told you to multiply 124 times 31, you would write 124 times 31 and get to work. You'd have the 4 and the 1 lined up, 2 and the 3 lined up, okay? Now if I take those same numbers and just drop decimals on them, so 1.24 times 3.1, you would still write it just like 124 times 31. It would still look exactly the same as that, except you just have all of a sudden a couple decimals in the problem. But the decimals do not need to line up, okay? Do not need to line up. Multiply it like you would a regular problem. At the end of the problem, once you've multiplied it out, gotten your answer, at the end, now go back to the original problem and count how many decimal places you have in that problem. Decimal places is any number that appears after a decimal, okay? So my example of 1.24 times 3.1, you'd have the 2, the 4, and a 1, 3 after the decimal. So therefore, when you get your answer, you'd come back from the end 3 places. And again, hard for me to explain it to you without showing you. Great example at the top of the book, showing you coming back 2 places. It's 2.24 times 5. If you multiply 224 times 5, you get 1,120. 2.24, there's 2 decimal places there. There's no decimal places at the bottom. So you're coming back 2 places. Past a 0, past a 2, 11.20 would be your answer. And many examples at the bottom, and these problems here, the math's already done for you. It just wants you to get used to where to put the decimal place at. And a key thing you'll see here at the bottom that's was part of the word problem thing is the word of. Remember the word of, especially when you're early on we're dealing with decimals, fractions, means multiply. So if I say what is 0.02 of 20, that just simply means you're doing 0.02 times 20. So the word of just simply is multiplication. Just put a multiplication sign in place of the word of, and you're set. Next page is continuing to multiply decimals. So it's just basically continuation, more work, more practice on those problems. And obviously, as you can see by the problems, hopefully, the book, it's making you kind of, it'll say what is 1/10 of 1/5. Well, obviously, when it says 1/10, that's forcing you to be able to change that 1/10 into a number. Change 1/10, the word, into a number. Obviously, 1/10 will be 1 in the tens place, 0.1 or just 0.1, and then times be of 0.5. And the next problem, what is 3/10 of 0.09? 3/10, same thing. 3 in the tens place, so 0.3, and then multiply that times 0.09. And again, hopefully everyone's got the book. You can see those, kind of self-explanatory. Dividing is the challenging one of the bunch. There's 3 rules of thumb when you're dividing decimals. I shouldn't say 3 rules of thumb. There's kind of 3 different styles of problems. The first one is dividing a decimal by a whole number. And the example is 6.04 divided by 2. The 6.04 would be underneath the bracket then, 2 on the outside of the bracket. These are nice because they're nice and easy. If there's no decimal on the outside, if it's a whole number, then the decimal on the inside, just move it straight up on top of the bar, place it there, and then do division just like you regularly would. 2 into 604, which is 3.02. Okay? So the decimal in that case just goes straight up above the bracket, place it on there, and then it's done out of your way. Shouldn't be any problems. That page is pretty self-explanatory. Just always remember at the bottom, they start out doing the bracket for you. Starting with number 7, it's starting to write it 10.5 divided by 21. Remember when it's written like that, the first number goes inside the bracket. So 10.5 would be inside the bracket, 21 on the outside. So it'd be 21 bracket 10.5 inside, divided out. If you flip the page, 48, and actually, 48, you're dividing a decimal by a decimal. These can be a little tricky. If there's a decimal on the outside, and as you can see by the example, it's 0.528 divided by 0.33. So when you set that up, on the outside there you have a decimal, 0.33. Therefore, you need to make that a whole number, and to do that, that decimal needs to come over 2 places to the right. So it needs to come past both 3's to make that into a 33. Whatever you do to the decimal on the outside, you have to do the decimal on the inside. So on the inside you have 0.528, therefore that decimal needs to come over 2 places on the other side of the 2, between the 2 and the 8. Now the problem is turned into 33 divided into 52.8. Okay. When you do that, obviously you can see 33 into 52 once, a remainder of 19. Bring down the 8. 33 into 198 6 times. No remainder. 1.6 therefore is your answer. All right. So again, as you can see at the bottom, if there's a decimal on the outside, you need to move it over to the end to make it a whole number. And sometimes move over 1 place, sometimes 2. There even may be some where you move it over 3 places. But however many places you need to add it or move it on the outside, you have to do the exact same thing, reciprocate it on the inside. So if you move 1 place on the outside, move the decimal 1 place on the inside. Move a 2 on the outside, move a 2 on the inside. All right? Mirror images of each other, whatever you do, like a scale. Same principle over in 49, except for this time, inside the bracket, they're whole numbers, not decimals. So the example on the top of that page is divide 28 by 0.4. So inside the bracket you have 28, on the outside 0.4. To change that 0.4 into a whole number, it needs to move over just 1 place on the other side of the 4 to turn that into a 4. Now on the inside you do not have a decimal. Okay? This is where a lot of people get these wrong. You need to start out by placing a decimal in there, and it goes at the end of the number. So put it right after the 28. If you put it anywhere else, you're changing the value of that number. If you put it in front, it becomes 0.28. If you put it in the middle, it's 2.8. Huge difference. If you put it after, it doesn't change anything. It's still 28. So put it at the end of the 28. But since the one on the outside needed to move, you still need to move it over 1 place. In order to do that, you need to add a 0. So 28 becomes 280. All right. The book sets it up very nice. Shows you moving the decimal. Shows the 0 being added. Therefore, the decimal is after the 0 up top. So when you divide 4 into 280, you get 70. A lot of times these problems are missed because people forget that second 0. They just take 4 into 28, 7 times. There's no remainder. They think they're done. But remember, you added a 0 there to 28. Therefore, you need to add a 0 up top to make it 70. I can honestly tell you on page 49, almost all these problems you're going to have pretty large numbers. If you do not get an answer that's a pretty large number, there's a good chance you did not add enough zeros. Okay? So if you get an answer of like 12, probably missed a 0 or 2. If you get an answer of like 22, probably missed a 0 or 2. Look for answers like 400, 500, 700, things like that. The pages after that, the 50, 51, and 52 are basically word problems, and then like a skills checkup. The skills checkup obviously is kind of like a quick review of the chapter. You know, kind of a rundown. It's almost like a quiz that you kind of take yourself. Each section of the book, I think it's every section, ends with using whatever you've done in word problem form, and then a kind of a quiz. It's called a skills checkup, but that's why I always emphasize the word problem too, because there's always going to be a section at the end of, about word problems. In the skills checkup, it kind of mixes between just regular problems and word problems. So you're going to use basically the skills we've just went over to put them into practice with those two things. I think that's it. I'm gonna look into. I'm trying to figure out how I can possibly record this to where the book or the board would be facing it to where it wouldn't be backwards, because right now it's set up uh, facing back to me, which means everything's kind of like a mirror. Everything's backwards. Because it's really, I'm finding it now. It's even more hard than what I was originally thinking about trying to explain some of this stuff without writing anything down. Verbally explaining math right now to me is like, it's like I'm trying to teach Chinese. That's how I feel. So I apologize because I feel like it's hard um, to follow along. That's why I'm in prayer. I think that everyone has the book, that they're not having any difficulties with it, or they've just kind of blown it off, because online this is absolutely critical to have it. Um, Unless this material is just entirely piece of cake for you. So if it is, bless you. Uh, but that's it right now. Again, I would imagine with this, I look forward to there being some actual questions on the discussion board, because I know that, like I said, without verbally or without um, being able to visually see it, it kind of creates more of a in your head. Um, what I might try to do is maybe locate on YouTube maybe a video that kind of breaks some of this stuff down. Maybe I can tag it into like maybe somebody else has a good setup where they're showing all this, and it's maybe a short video. I'll look for one of those, hopefully line it in. And I'll put on another thing. Apologies for getting started late this week. We had some issues, I think, with some people getting registered and getting logged in. So we extended the week, and I was trying to get everybody caught up before we really jumped into week 2. But I think we're good to go. All right. Well, any questions? Go to the discussion board, and if not, I'll look for that video. I'll try to get the quiz up, like I said earlier this week. Now that I know what I'm doing, and it seems like I can kind of do things without too much kind of trial and error, I think I should be good. So hope everyone's having a blessed week. So keep praying for each other, pray for me, and we will get through this with flying colors. Take care.